Previously, we studied several toy apparatuses for the homopolar motor, but now to do proper physics we need a good apparatus with more power and more accuracy. So what I'm using is the principle of magnetic suspension to hold the magnets up. I've got a big ferrite ring magnet here from a speaker, 225 millimeters, holding up 3 neodymium magnets, 20 times 10 millimeters each, so 20 times 30 in total. And they sit on a stainless steel rod of 5 millimeters, which conducts electricity. Now for the power going into it, I've got a storage battery here, 12 volts, 7 amps. You can buy this for $25 in Bunnings, for example, any hardware store. I'm putting it through a DC speed controller to control the power and voltage coming out of it. And the leads coming out of that, the black lead is a little battery cable attached to the stainless steel rod above the magnets. The red lead over here goes to a copper wire brush. Simple, just strip the wire. And what we're going to do is, when we attach the brush to the outside of those magnets here, current will flow from that lead through the magnets out through that lead, and the magnets will turn quite rapidly. Let's watch to see how that works now. Okay, I've set the DC speed controller to full power. Now I'm going to pick up the copper brush here, put it up on the side of the magnets, and we'll watch what happens. They start spinning very rapidly. Another clever thing we can do is take these magnets, some of them, place them down in the middle of the ring magnet where they're supported with the opposite polarity. So now north went to south and south goes to north. We'll put the brush on and now they'll spin the opposite direction. Next I've placed a series of 40 times 5 millimeter magnets on this steel rod, 40 times 15 in total. I've got the DC power controller on full. We'll put the brush up here and see what happens. They spin quite quickly with a bit of smoke. We can likewise have 3 50 millimeter times 5 millimeter neodymium magnets stacked together, so 50 times 15 in total. Add the brush at full power and watch them spin. Using this magnetic suspension system, we can study the physics of a homopolar motor quite accurately. We have a big ferrite ring magnet here holding up 3 60 millimeter neodymium magnets on a 5 millimeter rod of stainless steel. And we have a storage battery here, going to put 12 volts into it, red and black. Now one of the leads goes to the axle, the stainless steel axle, and that sends current down here. And if we put a brush along here, it'll complete the circuit and we can watch how the magnets spin. Here comes the brush. So it smokes a bit, but you can see the magnets spin quite nicely. Now, however, if we do exactly the same experiment, except instead of having a movable copper brush, we tape the wire to the side of the magnet and tap the power. Watch what happens. We get a series of torque motions, but the magnet doesn't spin. So what happens is each pulse of electricity makes the magnet spin a little, like in a Lenz sense, but it doesn't give continuous rotation of the magnet because the wire here is in a fixed location. If the magnet can move and that wire can move to another part of the magnet, then it would give continuous rotation. But it only gives you like a pulse, like for a jumping ring, because it's a temporary phenomenon as the current goes up. And that's the principle of the homopolar motor. Once again now we'll do exactly the same thing, except remove the tape and let the magnet spin. So we've learned something about physics here. You have to use a brush and not a fixed connection in order to get continuous rotation of the magnet. If you tape the wire on, you get a pulse due to the quick change in current, but you don't get continuous rotation. It's like a Lenz effect rather than some other kind of effect, like when an iron ring jumps up when you add the current to it. We can watch this same effect for low frequency AC power using a little flip polarity switch. Here we go. That's what happens when we change the polarity from plus to minus coming out of this battery, where there's no brush connection, just a solid connection. The disc moves back and forth like that in a zigzag fashion. If you don't have a storage battery, you can also use a DC power supply at about 5 volts. It'll run to about 30 amps when we turn it on. Just put a little on-off switch so you can control it. Come over here, get the brush, go next to the magnets. And they spin quite nicely that way in a controlled fashion. 21 amps if you look at the screen. Not too bad. When using a device like this, you may want to keep cutting clean copper brushes in the wire so you get good contacts. Also, you may want to clean the rod from little black marks of carbon using WD-40 anti-PDFD lubricant or other little metal type sandpapers just to clean the stainless steel rod up so you get good contacts.